Welcome to the continuation of my videos in reinforced concrete design based on Eurocode 2. It has been a long time since my last presentation and now continue with the work example of moment redistribution. See the same textbook. Work example. Here's the question. Design a section with moment redistribution applied and delta equals to 0.8. This section is subjected to M equals to 230 kN after 20% reduction due to moment redistribution. Given Fyk, which is the strength of steel, equals to 500 Newton per mm square, and Fck, which is the cylindrical concrete strength, equals to 25 Newton per mm square, determine the area of reinforcement needed using the constants K1 and K2 from A, EC2, and B, UK annexed to EC2. We start to answer based on EC2. Limiting the neutral axis step, we have this equation. If you can't remember it, please watch back the previous video. Rearranging them, we have X balance on the left. I want to remind you that the term balance here refers to both the concrete and tension reinforcement are designed to reach their maximum capacity, meaning no wastage. We bring the equation to the top. According to EC2 clause 5.5, the value of K1 and K2 are 0.44 and 1.25 respectively. We substitute those values and get this. How do we get this number? 0.8 is delta, which is the proportion of moment after redistribution. 0.44 is K1. 1.25 is K2. 490 is the depth of tension reinforcement. The calculated value of X balance is 141 millimeters. We store the value at the bottom left and proceed to calculate the depth of the stress block S, which is 80% of X. Substitute the value. In case you forget, 141 is the value of X balance calculated earlier. And the answer is 113 millimeters. We store the value at the bottom left and move on to calculate the level arm. This is the equation of the level arm. Plug in the numbers. 490 is the depth of the tension reinforcement. 113 is the depth of the stress block that we calculated earlier. The answer is 434 millimeters. Store it at the bottom left. Moving on to the moment of resistance. Moment equals to force times level arm. Revealing the components of the makeup concrete force. Plug in the values. 25 is the concrete cylindrical strength. 260 is the width. 113 is the depth of the stress block. 434 is the length of the level arm that we calculated earlier. 10 to the power of minus 6 is the conversion factor from Newton mm to kilonewton millimeter. The answer is 181 kilonewton meter, which is lesser than the imposed moment of 230 kilonewton meter. This means we need compression reinforcements. Checking the yield of the compression reinforcement. If you can remember in the earlier lessons, you know that just because we place steel bars at the compression zone does not guarantee that they will produce the full strength. Full strength of 500 Newton per mm square can only be achieved if the reinforcements are fully yielded, something which we must check now. Taking the ratio of depth of compressive reinforcement to the depth of a neutral axis. 50 is the depth of compressive reinforcement. 141 is the depth of the neutral axis. The answer is 0.35, lesser than 0.38. This means the compression reinforcement have yielded. We can use its full strength. Let us calculate the required compression steel. This is the equation. Plug in the numbers. 230 is a moment imposed on the section. 181 is the moment capacity of the section without the compression in reinforcement that we calculated earlier and stored at the bottom of the screen. 500 is the stress capacity of the steel reinforcements when yielded. 490 is the depth of the tension reinforcement. 50 is the depth of the compression reinforcement. 10 to the power of 6 is the conversion factor from kilonewton meter to newton millimeter for the moments. The answer is 256 millimeter square. Store the value at the bottom and move on to calculate the tension still. This is the equation. Plug in the numbers. 181 is the moment capacity of the section without compression reinforcement that we calculated earlier and stored at the bottom of the screen. 10 to the power of 6 is the conversion factor from kilonewton meter to the newton millimeter for the moments. 500 is the stress capacity of the steel reinforcement when yielded. 434 is the value of the lever arm. 256 is the area of compression reinforcement calculated earlier. The answer is 1215 millimeter square for tension reinforcement. Here are the answers to this part of the question. The areas of reinforcement for tension and compression is given inside the red box. That's all for now. In the next video, we'll try an alternative way to calculate the required area of reinforcement. Bye.